Cisco foundations, network components, diagrams, cables, and speed. When I say foundations, that's really what this nugget represents. It's going to be the foundation building block. I just envision a building being built. This is the concrete slab. Without this, the building's not going to be very stable. So we're going to describe what a network is all about. What role does Cisco play? How did Cisco become this stellar company that they are? What is the structure of this? I mean, what are the major components of the network that you're going to run into day in, day out as you are managing your network? And then how do we handle speed? I mean, we have some people say megabytes per second, some people say megabits per second, gigabits per. I mean, what does that mean really? I mean, tell me what that means. We'll unpack that. And then finally, I want to show you some of the common cable types that really lace your network together. So here is where the series starts. It's with the question, what is a network? And I have to be honest with you, when I wrote that and asked that, I kind of sat back and I go, well, blink, 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 just kind of staring blankly, because being in networking as long as I have, I'm like, oh, that's so big. There's such rich depth that you could go into with what is a network. How do I describe a network? I mean, it's so big. But when you take a really big step back from networking and all its complexity, it's really a technology that has been going on since the beginning of time. We've just been making it faster and faster. I mean, at the beginning of time, you had people in forests and deserts, and they're all trying to find each other. They're walking, trying to, I'm thinking, hacking their way through with knives, but we didn't have that. They're pushing bushes aside, trying to find each other to communicate, to trade resources, to barter, all those kind of things. And we just have seen it ever since the beginning of time getting better and better and faster, more efficient. I mean, people started moving into cities together. The turn of time, we see Rome building roads to try and make their communication faster. And that's why Rome ruled the world, as they built a massive road infrastructure for resource transmission. I can't even talk in old language. Moving stuff from around the world faster and better. And we've since then we've seen the car, we've seen telegraphs, telephones. You just kind of watch this evolution. We could draw a timeline where it just keeps getting faster and faster to where here we are today. Your job really is a road builder, and your goal is to make it as fast and efficient as possible for us to communicate. You're building the fabric of communication for the stuff that is important to us nowadays. The stuff that is important has moved away from goods, to where it's like, oh, look, I have a widget, although there's still plenty of that there. It's now information and communication. I mean, if you look at, what's cool, what do people want for Christmas kind of thing, they would say, oh, well, I want an iPad, I want a new laptop, I want a computer. But what are all these things? A window to communicate. I mean, if you look at an iPad, it's just a fancy, lightweight window that you stare into to gather information. The iPad itself is nothing. People go, oh, well, it's great. But I mean, if you look at it, you're like, I am holding a piece of metal with glass on top of it. That's not the value. The value is that on that screen, I can get all the information that I have, because that's where value is placed in today's world. Resources, information that's communicating. I mean, to the point where I just had one of those, weird kind of stare at each other discussions with my wife yesterday. We were looking at our bank account balance online. And trying scratching her head, going, there's some issues there. But and I looked at her. I said, you know what? That is just a number that we're staring at. I said it's a digital number. I spend hours and hours a day trying to make that number bigger. But you know what? It's not tangible. If the bank were to have a massive failure and backups were destroyed and all that, that number would go, it's gone. It's just there's nothing physical behind that number, and yet that's what is important for today. I have these little magic cards that make that number smaller wherever I go. But that's what the way that our world works is through this information technology world. So what is a network? It's roads. It's just really fast roads to communicate in today's world. So now let's bridge that into, okay, what is Cisco? Well, it started in 1984, and what company doesn't begin with some kind of weird controversy? They are the debated inventor of routers. That's their claim to fame. We invented the router. Although, if you go to Google and type that in, you'll find a 60-some-year-old guy going, "No, I'm not. I invented the router, and Cisco stole it from me." Whatever. Sure, okay. So maybe there's a 60-some-year-old guy who invented the router, and Cisco stole it. But undebatably, Cisco took that concept and marketed it to the world, mass produced it, and made it available everywhere. So that's Cisco's claim to fame, is they invented one of the cornerstone building blocks of networks nowadays. So today, Cisco is undebatably the industry leader in stable network equipment. Meaning, when you look at, okay, that is a solid network, you're looking at most of the time it's being built on Cisco. They have the vast percentage worldwide of the network infrastructure attributed to their name, and they have a reputation for stability. Now, they will tell you right up front, and I've been going to Cisco conferences for years and years, hearing constant speaks from their CEO, and he is always on board. He says, "We are a software company." Just like Microsoft. When you say Microsoft, immediately you go, "Oh, well, Windows, right? Microsoft Windows, that's what they create." Or Microsoft Office. They go, "We are a software company." And people don't have an issue with that because they realize I can go buy a Dell, an IBM, HP, a computer, and I can put Microsoft Windows because that's the software that goes on there. And Apple, we're a software. Apple, makes this amazing hardware, but they, they're really, OS X is their software. Now, Cisco unfortunately got the reputation. They're like, "Oh, well, you sell these boxes, switches, and routers and all that kind of stuff." And they have tried with all their might to say, "Well, yeah, but anybody can sell the hardware. Anybody can sell a really good piece of hardware. It's probably all manufactured in similar facilities." What differentiates Cisco is not just the hardware, it's the software that powers that device. Their software is known as the iOS, the Internet Network Operating System. That is their claim to fame. That is what provides all of the features, all of the configuration, and a vast majority of the stability that you experience with Cisco. Now, I do want to take a moment to mention that stability comes at a price. I mean, if you're used to walking into retail stores to buy network equipment, I mean maybe a small or mid-size or home office, and you're like, "Okay, I need a 24-port switch," and you walk into Fry's Electronics or Best Buy, and you look at the shelf, and you're like, "Ooh, $130, ouch!" It's like, "Oh, I guess that's what I have to." I wonder if Cisco's any cheaper. You come home and do a little googling, and you're like, "Oh, well, Cisco 24-port switch is just $2,400." Boom, body hits the floor. I mean, it's like, whoa, seriously? Yeah, seriously. But keep in mind, we're now into enterprise pricing. It's not like Cisco is, way above everybody else. If you look at competitive products that are offering or claiming to offer the similar stability, I mean, they're in a similar price range. Everything runs on the network nowadays. So stability is huge for an organization. I mean, at this point, that if if a business loses their IT infrastructure, if that's down, business stops. It's done until that comes back online. And if you want to find a quick way to take out the lifeblood of an organization, take out the network infrastructure. If that goes down, the organization literally stops functioning. I mean, which causes massive losses initially and can actually cost the company itself if left that way too long. So let's look at the building blocks. These are, when I think, okay, what is a network? There are some core building blocks that makes this thing tick. Number one is switches. The switches provide an interconnection point for all of your local area network devices, LAN, to where we have, let's take a switch over here. We have a cable run from that switch. I'll show you this in actually just a moment. Run through the ceiling. If we were to rip the drywall out, we would actually see it come over here to a wall jack, which, since we ripped the drywall out, is now dangling on the floor. But this would have a cable that would go to the PC. But, all of the cables that run through our company come back and terminate at that switch. And if we just plugged PCs and servers and everything into a switch, we could have communication. It's local area network communication. So I could, send a file from this guy to this guy, or store a file on a server, or maybe have a printer that everybody is sharing and using instead of everybody having to purchase their own individual, inkjet printer. Those are horrible to support, by the way. So you have all of this communication that can happen within the organization. That's all facilitated by the switch. Now, eventually, I would say probably sooner than later, people say, well, we need to communicate outside of our organization. Now we come to the function of a router. A router allows you to communicate, instead of within your local area network, to a wide area network, a larger network. Essentially, the router marks the dividing line between your network and some other network. So, and by the way, I'm putting these little symbols on here because you can't draw them very easily using these. So these are common, well-known symbols for a lot of these network devices. So we can have, Joe and Bob that are communicating on their local computers, but eventually they may want to go out to reach, and where do most people go? Whether it's a good thing or a bad thing, it's the internet, the network of networks, where all the resources come together and people are able to access all of those resources from here. So the router marks the dividing line between your network and the internet. Oftentimes provides a security boundary, but also keeps your traffic contained. So, when I'm having all my communication go through here, a lot of times we'll have floods of information. We'll talk about different kinds of messages, but you might have broadcasts that are going up and around and flooding through your whole company. Well, it just wouldn't scale if everybody's broadcast from their company would start leaking out here and, everybody would start seeing each other's traffic. Yeah, it just doesn't work that way. So a router marks the dividing line between network entities. Now, I could start adding things that I think a router should support. For example, I could add in like security. That should be a huge function of your router, to provide a secure boundary. But it's not required. It's just a boundary. I would think that a router would do a service known as network address translation, translating one kind of IP address or addressing of your network into the addressing of the internet. And that's a great function, and almost 99% of routers do that, but it's not required. Again, what does a router do? Creates a dividing line from your network to theirs, from your world to the rest of the world. Now we come down to wireless access points. Now become a core building block. I still remember to this day when I first set up wireless inside of my house. It was like a $200 802.11b D-Link wireless access point that I bought from the store. I came home, hooked it up, and I got one of those big fat PCMCIA cards, slid it into the laptop, and I sat on the couch in my shorts, and my wife goes, "What are you going to do?" And I go, "I am going to get on the internet." A moment of silence, click, click. And then just when that web page appeared, I lifted my laptop into the air, and I looked at Sue. I go, "I am on the internet." And then I proceeded to run to every single room of my house, going to a different web page. And she could hear me throughout the whole house going, "I am still on the internet." It was just one of those groundbreaking technologies that changed the world. And then within a year, you now have corporate executives going, looking at IT people, "What do you mean it's not secure? We need our wireless. How do we function without wireless?" It's so quickly permeated the world. And it's funny, without a modern security standard that would even hold up to anything. Wireless became a huge security vulnerability, but nowadays has become quite secure and allows you, in a nutshell, allows you to take your network to the air. If I want to expand my local area network into areas where wireless devices such as laptops, iPhones, iPads, blah, 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 you fill in the blank of what wireless device you have that needs a virtual connection out here to this switch, that's what the wireless access points do. Now, mind you, wireless is a massive step backwards. Now, I'll talk about that when we dissect wireless fully, but it is a big step backward from a switch. If you have a choice, you're sitting at your desk and you go, "Oh, look, there's a cable there. I could plug in my laptop, or I could use the Wi-Fi." Chances are pretty good you're going to get a better experience if you plug in your laptop. So, still to this day, local area network connections, wired connections, are far better. Now, we come down to the last piece, of course, the core of everything, clients and servers. It's like all of this stuff is one of those, if you build it, they will come. But if you just build all of this without the clients and servers, it's like can't live with them, can't live without them. You got to have users and resources on your network. So clients and servers represented by these kind of icons. These are your hosts, your users that are consumers of information, and then you have your servers, which are your storage of information. Now, you might have noticed on that last slide, I was starting to make the transition from the physical to the logical. On the left side of the slide was all these physical devices. Like that's what a switch pretty much looks like, a router looks like, just kind of examples. But then I had a little arrow kind of transitioning them into symbols that look like this. Usually when you're moving into the Cisco world, you're in a world of logical thought. There's actually the deeper you get in the Cisco world, there's less and less physical stuff that you end up doing. And for most people, Cisco is not the first IT career that they have. It could be. I'm not saying that's the rule. I'm just saying most of the time it's not. Most of the time people have worked in Microsoft, doing file shares and server maintenance and updates and printer management and all that. And they go, I think I'm ready for a change. So they kind of start learning networking. Or a lot of times a very common way is people are doing cabling. They're running network cable. If I could talk right at the same time, running network cable through walls or new building that they're setting up, and they're doing all this hard work and bending their fingernails back and crimping and all this kind of stuff, and they move and bring this network cable, and it comes to a guy who's dressed pretty nice and doesn't have dirt under his fingernails, and he goes, oh well, thank you, and takes that cable and plugs it into the device and keeps typing away on his computer, and people go, oh well, can I do that? I'm kind of tired of running all this cable. Not all the time, but that's a common transition. So what I want to do is kind of really make that bridge between the physical and the logical. So we're going to start seeing network diagrams that look like this. Like this would be a really small office network that we would have. We've got over here one computer, one server, and they're plugged into a network switch. Now I've got to make sure that I match this is what you see on network diagrams all the time, but there's so much represented in that line. Like over here, this is where the switch is actually installed. It's in a rack of equipment sometimes. Sometimes it's sitting on top of a desk, sometimes it's velcroed to the wall. I've seen all kinds of crazy stuff that people have done, but this is typical where they have the switch mounted down here. Now notice all of these little ones, they look like switches. There's all kinds of cables plugged in, but those are actually called patch panels. So you actually have all of the cabling, not shown here, that is run through the wall. It's all running up here in these nice neat cable runs that come into the back of this system, this rack, and terminate into these patch panels, which are literally just a patch. I mean, it comes in on the back. It looks like this on the back of them, and then on the front it has a little network jack. That's all it is. It's a dumb device. There's no intelligence in it. And we take that and run the cables down. This must be another switch up here, but we run the cables down and plug it into the switch itself. You might say, well, couldn't you just take the cables from the wall and plug them straight into the switch? Do we need this patch panel? You could plug it into the switch and it will work, but using a patch panel gives you a lot more flexibility and mobility. Like for instance, I go, oh man, I need to squeeze a device in right here. Well, all this cable may be, cut right at the edge, and there's I can't pull any more out of the ceiling. So by putting it into a patch panel, I now can use these little jumpers to stretch it. You can see like these are little short jumpers right here, but down here we stretch some nice long network cables. Got a little messy right there. It would not pass my inspection. Into the switch and bundled them all, connected them all into that. So it gives us a little more flexibility with where we go. Now, so that's this is where this device is stored. But if you take that and follow this one of those cables through the ceiling, it actually comes into the drywall and then comes into the back of a plate here. And here's just a network jack, which takes that plate, puts it in the wall, makes it look nice and flush and pretty, where I can plug in my network cable, and I take a patch cable, that's often what we see here, and then plug it into the back of my network device, and now that device this is kind of like my little flowchart, has network connectivity. So this is my computer that I'm plugging it into. Side note completely, it just popped in my head, where do you get this network cable? Do you make these yourself? Do you buy them? I would say nowadays it's probably best to buy them. And I'll just throw out, this is bonus material here. One that I use all the time, monoprice.com. Good grief, this company is amazing. Based out of California, they're amazing because I live in Arizona, which is right next to California, and they just have every color, shape, and size. Half foot. You could get pink cables. Goodness, 1 foot. You come down 2 foot, and essentially the more that you buy, and these prices, first off, are phenomenal. I went to Fry's Electronics just the other day. I paid, what did I pay? Because I needed them. A 7 foot cable cost me $6.99. I'm like, good grief, that is painful, but through Monoprice you can get them really cheap. So not a commercial for them, just saying that there is an alternate way than just going to a retail store and forking over a mortgage for this. I would recommend buying pre-built cables rather than making your own. Number one, there's a huge time savings in that, kind of the time money trade-off. But also there are people that have equipment that make these things professionally and test them professionally that will always beat a human hand moving these little 8 pins into the cable and try twist it. Got it. Okay, you're always going to get a better, more reliable cable from a machine-built system than making them yourself. So that's the physical side of it. Now, all of that, this little flow chart right here is represented in this little 90-degree angle line. That's really what's going on behind the scenes. Now, that switch eventually connects to a router. Most of the time, it's going to be sitting in that same rack. Maybe it's mounted right here. And that router has a wall jack here from the internet service provider that is coming in that delivers the internet connection. Again, being that dividing line, taking data that needs to go to the internet and sending it out there, but the stuff that is supposed to stay on the local area network, that's where this guy becomes the wall and blocks it. It blocks the stuff that's supposed to stay on the internet, protects it right here, and blocks the stuff that's supposed to stay on your LAN and protects it right here. Only allows the stuff that's supposed to go between these two between them. The deeper you get into the Cisco world, the less and less physical representations of things that you'll see, and the more and more logical. When you get to the point that Cisco is all you do, a lot of times you're just looking at network diagrams and accessing devices that you'll never see or physically touch. They're somewhere elsewhere in the world. You're just managing them and monitoring them on a remote basis. So less and less physical, more and more logical, and yet this early on in the series, I find it hugely valuable to say, well, I don't want to have a disconnect when people say, oh, well, it looks like there's a line there. Well, this line is oftentimes represented by an Ethernet cable. And that's one of the most common types of cables that we'll see connecting our clients, and most of the time even today, our servers. You'll see all kinds of different standards of Ethernet cable, from the old days, Cat 3, and as it progressed into nowadays we have Category 5E and Category 6. And as we're increasing the standards, we're just moving up in quality levels of this cable. Remember, I went back to what is a network? It's just faster and faster and better and better. If you took a razor blade and stripped all this shielding off, you would find the 8 individual wires inside of there that as these categories move further, you just see them getting tighter and tighter and twisted, more interwoven, because the tighter you twist these guys, the better protection you get from electromagnetic interference. It's kind of like as you send data down this and it kind of spins the data over that wire, it creates a little electromagnetic physical shield. I shouldn't say physical. You can't touch it, but it's like a protection from interference. One of the best things you can do to destroy your network is create your own cable to no standard. Like you say, okay, well I want red and blue and green. I'll just put them in whatever order I want and then match that order on the other end. Well, you're not going to get the correct spinning, if you will. You're not going to get the correct field, and you'll never get the length that cable should be, which is 100 meters of distance. Now, in recent times, I would say, well, recent being the last decade, we've started to see new ways of communicating with fiber optic cable, where instead of sending electric signals, we're sending light waves, which are way less prone to interference and can travel a lot further. Instead of looking at 100 meters, you can start getting into the different kinds of fiber, like single mode fiber, which is a glass tube inside of there, and you can get into the miles before you have to regenerate the signal, and then you can regenerate it for miles miles and miles and miles. I mean, hundreds of miles these cables can go with regeneration of these light signals. And also the bandwidth that can be contained on these cables, it's still almost in theory, like how many different ways can we bend light to get more bandwidth out of these cables. So we're starting to see these kinds of connections primarily between switches where you have long distances between these guys, and also you have potentially 20, 40, 100 different devices connecting over here that are sending all their traffic over here where you need this high bandwidth connection. We're also starting to see fiber optic connections even for the servers where, not so much distance wise, but bandwidth wise, these servers need a much higher capacity to communicate on the network. So we see fiber optic cables. Now, I'm bringing this guy out. You go, ooh, that looks old. It is. Serial cables are still used in some places to bring up the internet connection. Like the service provider comes in, here's the wall jack. They bring in a wall jack right here, and you connect it to a device called a CSU DSU, which is really just a little cable translator. It comes in on one type and comes out on another, which is the serial cable. Now, these are now considered old school, starting to show up in museums. However, you will still see serial ports all over the place. I mean, T1 lines, those kind of terms typically come in when you're talking about serial technology. So serial is still alive and well. However, we're seeing a massive move of serial technology over to Ethernet, where everything is now being delivered using Ethernet technology. Maybe it comes in on fiber over here, fiber optic cable, but they've got a little transceiver, a little box that converts it from a fiber optic cable into Ethernet and brings it in there. I mean, you look at your home connection, right? You probably have, if you have high-speed internet, you maybe have a cable modem or DSL, which is taking a phone line or a coax cable on this side and translating it over to Ethernet on the other side, which you would plug into, whatever you have at home, your computer or your Linksys device. So that's the physical cabling that we see. Last thing I want to talk about here is now how fast does it go, and how do I really correlate that into something meaningful? Well, let me clear this off and talk about space and storage on our computers and servers, because understanding that is the key to understanding how long it takes to get that over the network, the speed of it. So most of what we do nowadays is in terms of bytes. Like that's the fundamental building blocks. We've heard terms like megabyte, gigabyte, terabyte. These are hard drive storage sizes and things like that. But break it down to its foundation. It's at a byte, which if you were to put that into something practical, you can think of a byte as one character. I'm going to open Notepad. Let's say I type in J. That is 1 byte of information. I'll put my name there, Jeremy. That's 6 bytes of information, 6 characters. Now, this is just roughly, something that we can say tangibly that is. I'm not talking about, for instance, you go into Word and you format it, you put bold, and I mean, it's going to have like 90 kilobytes, but at its root, a character is a byte. So let's just think of that. A byte equals 1 character. So a kilobyte is just like meter and kilometer. A kilobyte is 1,000 characters. Technically, it's 1,024. That's the increment that they use. So think of a kilobyte as 1 page of information without the margins, full of text. That's a kilobyte of information. So we take that further and we follow the scale the whole way down. 1,024 kilobytes equals a megabyte. And now you have to be in the dark ages not to have heard of a megabyte before. You're like, oh, okay, that's like memory on a computer. Well, I guess everything grows. It used to be. Now everybody's like, oh, gigabytes on a computer. And you see how this works. So think of a megabyte as like a long book with no margins, 1,024 pages long. So then we move into a gigabyte, and this game goes on and on and on. And I put ... because the petabyte, exabyte, yottabyte, zettabyte. I mean, it's just insane the values that they've come up with for storage, and it's insane how low cost and disposable it is. I mean, I remember teaching in my early days Microsoft Internet Information Server 3.0. Killer product there. Probably responsible for 90% of the hacking success on Microsoft systems. But nonetheless, I remember teaching that class, and I said, guys, this is a monumental day. Microsoft has released the Terra server, and I said it with a whisper in my voice, which it was Microsoft's first website that had a terabyte worth of space. It was maps of essentially the world, detailed maps that consumed a terabyte of space. We're all like, oh, a terabyte. I mean, oh, this, and now, $90 a 3 terabyte drive at Fry's Electronics on sale or something. I mean, it's just insane the amount of space that we have. So this is all storage space, right? Now, let's talk about the network. The network actually works and transmits in a value smaller than a byte. Now, you might say, well, how do you go lower than a character? Well, that's where the bit comes in and messes up everything. Because everything's 1024 except for the bit. There's actually 8 bits. It messes up the whole scheme here. 8 bits in a byte. You might think, well, how do you get smaller than a character? Well, you go to the very root and essence of computing. A bit is an on or an off. A 0 or a 1. And actually, I said that backwards. An off or an on. A 0 is off, 1 is on. And you go back to people who created computer programs in the 60s, and they were created on punch cards that they would feed into computers, and they would look at the, kind of hanging chads, what was punched out and what wasn't there. And, fast forward nearly 50 years, and here we have, Windows 8 and iPads and all this gloss and prettiness. But you know what? Behind all the prettiness is zeros and ones. We've just found a way to transmit these and process those really fast, which gives us all the glossy, backgrounds and everything else that we have nowadays. Now, coming back to the network handles speed in terms of bits per second, not bytes per second. I remember my dad a few years ago called me up. He's like, Chair, Cox Communications just upgraded me to a 10 megabyte per second connection. And I was like, oh, no way. I just freaked out. I'm like, Dad, that's amazing. 10 meg, are you serious? Like 10 meg, like I'm coming over to your house right now. And he's like, okay, what did I say? What did I say wrong? Just because, I'm like, well, Dad, it's not a 10 megabyte per second. It's a 10 megabit per second, because network is always in bits per second. If it was a 10 megabyte, big B, per second connection, then I would have to multiply that by 80, which is an 80 megabit per second connection that he would get. Which years ago when he called me was just unheard of. I mean, nowadays it's kind of like, oh, it's pretty good. I mean, it's just amazing. The speed has progressed so far. So I would say it's not. I mean, if you've done things like that, if you've called things like megabytes per second, and it's kind of like blended with. I mean, I can totally see why the confusion is there, because if you go in any web browser, and I think Internet Explorer was the first one to do this, and let's say you go download a file, like let's like, who uses Internet Explorer? So let's say I want to go download Firefox, right? And I say, okay, I want to download. Let's go to Firefox, download. So I look right here. And it comes up and says, okay, 16.9, let's go ahead and save that. And you can, come on, give me, there we go. You see that right there? 1.34 megabytes per second. And therein lies the confusion, is Internet Explorer shows the transfer rate in a way that the network wasn't really meant to transfer. I mean, I guess you could say it that way, but it's in megabytes per second. And that's, I'm sure, led to 1,000 support calls for internet service providers everywhere who, someone signed up for a 10 megabit per second connection, and they're like, man, I'm only getting transfer rates of like 1.5 or 2. I thought you guys told me, you fill in the blank. And actually, if they got 2 megabytes per second, they'd be getting more than they paid for. So you get the idea. There's just this big confusion. So what are the network speeds? Well, original Ethernet many moons ago was 10 megabits per second. Around the turn of the century, we saw that progress to 100 megabits per second. And within, I would say, the last 5-6 years, we've started to see 1,000 megabits per second. Now, what's the most popular? Still, probably to this day, it's this guy. But those tides are changing. I mean, when I first recorded IC&D 1 years ago for CBT Nuggets, I mean, I was kind of like, gigabit, who needs it? I mean, why would you need that kind of speed? That's the kind of language I was using. And nowadays, I mean, since then, we now have every device shipping with gigabit connectors, as switches are being replaced. I mean, it's just time has progressed, and now we're seeing really, I would say, I don't know, I would say maybe it's a 50-50 split, to where to the desktop you have 100 meg some places, gigabit other places, but there's a lot of speed. But I mean, we have faster speeds as well. We have 10,000 megabits per second. I'm saying megabits per second, but as soon as you go here, I mean, you usually start talking in terms of gigabit per second or 10 gigabit per second. You don't usually hear people say, "Oh, I've got a 10,000 megabit per second connection." And right now we're around 40,000 megabits per second, or 40 gigabits per second is the current standardized versions. Although there's faster that are in proposed standard. I mean, it keeps going nonstop. It just progress is happening. So what do I do with this? I mean, so how do I practically use this? Okay, well let's go to just a practical scenario. You've got a really high resolution, SLR camera that took a picture of your family and you stored it on your computer right here. Maybe that file is 10 megabytes in size. And that's really good high resolution picture. Although I know some of you photographers are like, I can do better than that, bigger. But let's say you've got that file, and I want to store that on the server. Well, it's just a quick formula, a quick math. You have to say, okay, well, that's 10 megabytes. Well, let's say I have a 100 megabit per second connection. What does that work out to? Bust out the calculator and you go, okay, well, like you need a calculator for this, right? Okay, 80, or wait, I guess if you're me, you do. 10 times 8, because I know that there's 8 bits in a byte, is 80, right? So I've got that. So really, I'm looking at a file that is not 10, but 80 megabits in size. So if I have a 100 megabit per second connection, it's going to take probably just under a second to transfer and store that file on the server. Now, that being said, that's theory, blah 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 blah. I say that just because when we send files across the network, here's your 10 megabyte file, right? Your computer busts out a Ginsu knife and it's like chops into all these little packets, which the current common well-known packet size is about 1,500 bytes in size. So you take your 10 megabyte file and chop it into a bunch of little 1.5 kilobyte or 1,500 byte size little bite-sized packets and send those, and each one of those is going to have some header data, like here's where it came from, the source, here's where it's going, the destination, port number. I mean, there's all kinds of overhead associated with that. So I would say you're probably, even though yes, I have a 100 megabit per second connection, you're probably going to only see, with all the overhead, maybe I would say 80 megabit per second. Again, just don't quote me on these numbers, just rough guesstimate, because of the overhead that you're going to get. So we're still at about a second. You see how that works? So I mean, a 10 megabyte file is like a picture. You could take this and say, oh, I've got my MP3 music collection of uncopyrighted music I've downloaded from legal sources, and I want to transfer that uncopyrighted collection off. So you can do that math. You can start saying, okay, well, if I have I guess let's do it. Let's say I've got a 1.5 gigabyte in size legal music collection. Well, first thing I would say is, okay, well, that's 1,500 megabytes in size, right? Times 8, because I need to figure out in megabits per second how that's going to work. So I know you probably can do it in your head, but I'm talking. It's hard to talk and do math at the same time. So 1,500 times 8. So I've got 12,000 megabits in data that I want to transfer. So I'm going to say, okay, well, if I have 100, again, theory, 100 megabit per second connection, where I was really getting 100 megabit per second of throughput. I mean, you could divide it by 80, like my rough estimate, and get a more realistic number. But let's just say in theory, divide that guy by 100, and I say, okay, well, it's going to take about 2 minutes of copying to transfer on a 100 megabit per second connection my 1.5 gigabyte file over to the server. Again, in theory. So does that make sense? So when we're really working with the network, always be thinking in terms of bits per second, and always having that mental shift of saying, okay, well, if I'm talking about a file transfer, that's likely going to be converting from bytes per second down to bits per second. Man, I wish I could be where you are right now. Right, this is the first nugget that I have recorded in this series, and I am like, for me, who I've been doing networking for close to 15 years now, of just working with it. So when I'm talking, I'm like, this stuff, oh yeah, I've done this all the time. But to be where you are, sitting hearing this, maybe for the first time, like I wish I could almost unplug my brain and hear it and just be like, oh, that's good. Okay, so that and then that and then the speed and then. I just think this is a great foundation, which is exactly what this is meant to be. So what have we seen here, and then what do you do with this? Okay, so what we've seen is what a network is, what Cisco, how where does this company Cisco come from? Why are they the gold standard in networking? They really started it all, except for that 60-some-year-old guy who's claiming no, it was me. So network structure, we saw the switch really building the function of the LAN, the local area network, providing local connectivity. We saw the router, we saw wireless access points, we saw the clients and the servers, kind of the basic fundamental building blocks of any network environment. We talked about the speed and network cable types like Ethernet. We saw some fiber connectors, and in this series, it's like I just want to explode right now with information, and I'm holding back because we will be unpacking each one of these more as we go. Again, this is just the beginning. So I want to come back to the question I asked. What do you do with this now? I know this is the first nugget you might have gone through to really get into the information. What now? Do you go on to the next one? Here's what I would do if I were you. I would stop. I would walk around my house because likely you have high-speed internet and just start looking and identifying. Okay, I see my network card on my computer. Okay, where's that go? Did I get my house wired for Ethernet? Maybe you wired your house yourself. And you kind of trace things back. Look at the switch. Look at the router. Again, just get the feel for your own network. Or if you're in corporate networks, oh man, if you're working at a company right now, stop now and go find the IT guy. Go find the network guru over there and just be like, hey, bro, could I get a tour of our network? I mean, I'll say me as a network guy, I would eat that up. I'd be like, dude, cool, dude, come on, yeah, let me show you this. And I'd be like, look, here's the switch, and I mean, he's probably going to show you things I haven't even talked about yet, which is just so golden. If you're not in an organization like that, go find one. Maybe go to a retail store and be like, hey, I'm gonna buy 3 packs of this chicken if you will get a guy to just take me back and show me your network. I mean, it may be weird, but I'm telling you, do what you have to do to get into a production network and just look around. If nothing more, start Googling YouTube videos for network tours or data centers or things like that, and just start identifying the equipment. All right, I mean, I can't tell you how excited I am to get in this series. So for now, I hope this has been informative for you, and I'd like to thank you for viewing.